I'm Sanchit Mehra and I'm back again with a new design pattern under the category of creational design pattern, which is a factory design pattern. Friends, factory design pattern basically is used when you have multiple subclasses or a derived classes of a base class. Okay, and there are multiple ways in which you can create the objects of derived classes. One is you directly call a new operator on a derived classes, right? So this is what the factory design patterns avoids for you. The factory design pattern do not want you to directly know about the derived classes, to know about the types of the, you can say, the derived types, and it wants that your client should be completely decoupled of whatever the derived class or whatever the object you want to create of the derived class. Okay, so this new operation, or you can say the new, when you instantiate the derived class with a new, that is encapsulated in a wrapper function, and that functions gives an object of those derived classes, of those derived type, to the client. Okay, so it's sort of a decoupling of the creation of the derived, of the objects of the derived types. Okay, so I hope you understand that in software engineering the decoupling is utmost important. The better the decoupled your code looks, the better it is, and the factory design patterns comes to the rescue for this. Okay, so let's first see what is the problem basically, and why we need the factory design pattern. Okay, and what problem does it solving right now. So let's first see what is basically the problem. So as I have told you that the factory design patterns comes into a picture when there is a class hierarchy, the type hierarchy, there is a base class and a couple of derived classes, and you want to create an object of those derived classes. And why you do not want to have a new operation or a new operator directly call on those types, and why uh, why it is good to have a factory design pattern when you have such a scenario. Okay, why? Because it leads to the decoupling of the creation of objects from your client. So let's first understand about the problem. Okay, so friends, let's see. I'll take an example. Let me take an example of like this. Say, so the base type I would be, let's say base type I would be taking as an employee, or let's say, yeah, employee, and I will be having two derived types, and let's say one is a developer and other is a tester. Okay, so this is what my class hierarchy is will be, and I will just be demonstrating to you about this creational design pattern, what's the problem, and how better the factory design pattern solves it. Okay, so let me first create my base type, which is an employee. So let me go here and create a new file here, cpp file. Let me give it a name employee. Also create an header file, yes, I want it, and let it be created. Yeah, so the IDE creates me the header file. In that header file I just declare my type, which is class employee, and let's say it has a function which is, let's say, call as void do work. Okay, just for a sample, I have made one method here which is called as a do work. Okay, and in my cpp file I just implement my method void employee do work. And since in this employee we do not know what kind of employee it is, I just write a simple like employee needs implementation. It's just a marker to, for developer to know, or for client to know that you are dealing with a base class and you need some implementation of it. So for this cout, I include the header file. Perfect. So I have an employee here, and the header file, I declare this class, I define the method here. So perfect. So in main.cpp, I would be including this employee type. Let's say employee in the double quotes, and include employee.hpp. Here I would be instantiating employee star employee equals to new employee. Okay, and here I have employee, which is called do work, and then I'll just, since it's created on heap, I'll delete this object as well. Okay, so this is the thing basically. Now I told you that I need two derived types as well, which is a developer and tester. So let's make those types as well. One, the developer would also be derived from employee, and the tester would also be derived from an employee type. So let me create another file for you. New file, cpp file. Let me call it as a developer, and I need an header file as well. Let's create. Perfect. So I have this skeleton here. In this developer file, I just define my class developer, and I derived it from, let's say, employee. Yeah. And in this employee, I also need to declare this as a virtual function, right? So I declare it as a virtual here, and in developer.h, okay, so this type is not known, so I need to include it here as well. Include here employee.hpp, and so now I have this type. I will just public, I will do void do work. Okay, so I just declare this method, which is a virtual in employee, my employee type. I have a developer class which derives from employee type, and I need to implement this method as well. So in my cpp file, I'll just go, the developer.hpp is included. I'll just implement developer do work. Let it be, I am a developer and I develop the code, I develop the software. Yeah. And I just, for the cout, I just need to include my IO stream. Perfect. So now I have the developer type, which is again inherited from employee. And if you see employee, it defines one virtual method do work, which I have an empty implementation or just simple base implementation of this function. And in my derived types, I literally something I develop it for, say, I just written out this like some kind of processing I do here. Okay, now let's say in the main, if I want to create a developer, an object of a developer, then of course I would be needing, let's say, employee star developer equals to new developer. I will create it like this, and developer, which is to work, right? So now if I compile this code, you see that my build is failed and it says unknown type developer. So since I'm using this type here to instantiate, or to call this to have this with new operator to just instantiate the object of developer type, and it's not present, so in my client code I need to have the developer type as well. Okay, so what it is basically, I'm coupling my code, or you can say my client code, uh, with the developer.hp, or you can say some a code of a framework. Okay, so or a framework that has some classes and subclasses. Okay, so here I'm tightly coupling it with developer type. My client code is getting coupled. Now it has a developer type here, which it reads it's from developer.hpp, and then it needs a recompile. So I'll just compile it. Oh, sorry, it's developer.hpp. I save it and I compile it. So it perfectly compiles, and if I run it now, so you see employee, this printout's perfect, and for the developer it's printout I'm a developer and I develop the software. Okay, now you see, if I have, or let's say the library, let's say these employee and developer class are maintained by some folks, or for some certain set of developers that develop this classes and subclasses. Okay, so let me come up with another sub class, or a derived class of employee. Let's say I commit with the with tester. Okay, I need the header and I have a tester, so same thing I can have it here. So let me have in tester.hpp, I just tester, I derive publicly from employee, and I just do work, and I will implement this virtual method also that I have declared in employee. So again, this type I've used, so I need the declaration here of employee. So I will include employee.hpp. So now my this will be known, the type this will be get from employee.hpp. I've included that, and this is my a tester type, which is again a derived type of this base class. And in my cpp, I just need to, let's say, give the definition of do work and std cout. I am a quality engineer and I maintain the quality of software. Okay, so now my friends, this tester class has come up now, and in my client code, if I want to use again a tester if I want to make an object of my tester type, so again I would need to do employee star tester equals to new tester, and tester do work. Okay, so again you see I need this type, I need this, what is the type, because in my client code I do not know about this type. So again I need to include tester.hpp. Okay, so that I have the type now, and it should compile it perfect now. So it's failing, so let me see where it is. Okay, uh, okay, this include is wrong. Yeah, so will failed again where it, let me compile it again. Okay, so where it is failing, okay, so here I need to have the void, and for the cout I need to include iostream. Perfect. So if I compile it now, my build is succeeded, and if I just run it, yeah, so here for the developer, I'm a developer. For this tester, I'm a quality engineer. So the do work get processed for developer, for tester, and for this my generic employee. And again I need to delete my developer, and I need to delete my tester to avoid any memory leak. Okay, this is just irrelevant right now because we are talking about factory pattern here. So my dear friends, there is a big problem here. This here, there you can see here, it's a tight coupling of the derived types with the client. Okay, so you see, whenever a new type has been added by a library person or by any developer, I as a user of that code, I or a library, I need to know that type, I need to include it, and then I need to write my if else and those things, and again I need to recompile. So I have a solid dependency on these derived types, and now I want to remove it. Okay, so the I need to decouple it. Okay. So the mechanism of decoupling is like, in my base type, I will write a wrapper function that will give me the objects that I want, and I do not need to know about these types. I do not need to know about the developer.hpp. I do not need to know about this tester.hpp. I will just give the library or an interface that give me this object of this type, and your responsibility will be to instantiate and return me the respective object. Okay, fine. So what I want to expose is one interface only. I want to expose this employee.hpp to my client or to my users of my library. Okay, so for example, I want to remove this. I do not want to expose developer, tester, or manager, scrum manager, whatever may be the multiple subtypes. I do not want my client to know about these types. So what I will do here is that in my base type, because I have this employer and interface class or interface type exposed to my client, I will use this class only to instantiate the objects of its own derived types. Okay, which is in this case is developer and tester, right? So what I need to do here is I need to have one static function, and it returns an object again of I'm having this base type because I know this base type, and I have one create function in which I will take the type. Yeah, so this is what my create function look like. It's a static. That means I do not need to create an object of employee to use this function, and it will be returning all the objects. It can return all the objects of that are of type employee. So in my case, since I have derived the developer.hpp from employee and tester.hpp from employee, so all my developer and tester are of type employee. So here we are returning it of the same type, which is an employee in this case. So guys, let's implement this create function here. So let me create it here. So I remove the static here. For the scope, it's the scope of employee class. I have a type here, so I can see if type equals to, let's say, developer, then return new developer, the object of developer, and if the type I get here is tester, then return new tester here. And if nothing is matches, then I can just create a object of base type and just return it here. Okay, so this is what my create function looks like. Now here again you can see this developer and tester, this types is not known to this employee, so I need to include this here. Developer.hpp, and here let's say tester.hpp. Perfect. So yeah, so here it is saying out of line definition of create does not match, and so let me see the type here in employee.hpp. Okay, so employee create std string type, and it's a static as well. And what is it here saying? um Employee create out of line definition. Let me compile it. Will failed, where it is failing right now. Okay, any declaration in employee. So do I declare this in employee class? Yes, I declare it. Static employee create, let me take this as a complete, and here I take it as, yeah, and here I have the scope of a class here. Let me compile it again. So did not match any declaration in employee. Okay, so this string, for this string I need to include this as well here, IO stream. I hope this would be an issue here. And then okay, so here I have the IO stream, here I have the create. So let me see the error, which is unknown type developer and tester here. Yeah. So here the developer and tester is not known because I removed the type from here. So I just need to call this create here. So here I have defined this create to return me the developer and tester here. So in this main dot cpp, I will just call employee create, and I want an object of type developer here, and here also I will comment it. I want create and tester. Okay, so let me compile it again. So it compiles perfect. So friends, I just decoupled my client with all the types of, all the derived types of, you can say, of type employee. So I do not know, I do not need to include the developer header file or any other header file of its derived type. I just need to know employee.hpp. In my employee.hpp, there is no, you can say, there is no any other user defined types here. It just a create function which takes a parameter to know what client, what type of a sub object or my client wants. Okay, so in this create function, what I've implemented is here, if the client requests for developer, I just return its that object. If the client requests for tester, I just return a tester object. So friends, here you can see that I have decoupled my code with many types. That could be any of the subtypes. So this is one of the beauty of creational pattern, that the client does not need to know the details of the subclasses. Okay, uh, maybe it also supports one of the software design principle, which is called extensibility. So now my client, which or you can say the my library or the folks who are working on this employee hierarchy can extend it to make some more subclasses. Like they could come up with product manager, which is again an employee type. They could come up with Scrum Master, which is again an employee type. They could come up with manager. So it can extend that in future, and my client code remains independent of that. Okay. Second thing is reusability. So I can use the same code employee create and employee create to at various places, and I can use this wrapper function to create any number of objects of whatever type I want to create. So I just do not, I only need to include an header file which is an employee.hpp, and it does not have any information of its subtypes. So, so whatever I make a change, I do not need to make any change in my interface. So, so this is in a sense is an interface uh, interface that is exposed to my client. Okay, so my client only knows of employee, and this employee undertakes the responsibility of creating an object of its subclasses that my client or the client demands for. Okay, so let's say how the extensibility happens here. So let's say I have one more subclass which is let's say manager, and let's say again, let's say my the couple of folks which are managing this employee hierarchy wants to further extend this class to another type which is called a manager. So let me include employee.hpp class employee, or not say let class manager, which is a new derived type that I'm making, public employee, and here I'm having, I implement the, I need to do work here, and in the manager.cpp I just implement manager do work I am a manager and I manage my team, just something as a placeholder. Okay, so again yeah, perfect. So perfect. So now I have this manager type as well. And now if I want to use or instantiate a type of a manager, I now do not need to call a new on manager here in my client code. What I need to do is again to extend this wrapper function. Again, I do not need to touch the interface. I just need to extend it here. If let's say type equals to manager, I just make an object of manager here and return. So again the type has to be included here, so I just haven't include the header file manager.hpp. Now it knows the manager, so build is yeah, let me recompile it again. Build is failing, so I hope everything is fine here. Expected. So now again it compiled, so build is succeeded. So in my base class which is a manager.hpp which is an employee.hpp, in this create method I just have the capability or the knowingness of how I will create an object of my subclass. So in my client code again, I am completely decoupled with my another type, which is a manager, which my library or some folks has come up with. They've extended the type of employee, and I just need to write employee manager equals to employee create, and I want a manager object here, and here manager do work. So now I compile it. It compiles perfect. So I do not need any information of my subtypes. It's just encapsulated in this, which is a factory design pattern. It gives you ability for a tight to low coupling of derived types or no coupling of derived types with the client. Okay, and that is one of the good design principles of software. So I delete it, and now if I run it now, you will see I'm a developer, quality engineer, and for this a manager. Okay, so my manager is working like a manager, my quality engineer is working like a quality engineer, and my developer is working like a developer engineer without me knowing its type, and without directly creating the new, or without directly creating the object of those derived types or calling directly a new operator on that. So it's an encapsulated, low coupling, reuse. These are the perfect examples or the perfect advantages of using a factory pattern here. Now, one thing is here, since I am deleting the code here, deleting the objects here, so uh, so I need to declare the destructor here as a virtual, or the, because if I do not declare the destructor as a virtual here, so I have to declare or write a virtual destructor here. So virtual destructor here, why? Because I'm calling a delete on a type which is of employee type. So to call the destructor of my derived type, I need to declare the destructor virtual here. I leave it for you as an exercise. Pause this video and just implement the destructor here and see whether the destructor of the derived types called successfully or not, and then use the destructor and then define the or declare the destructor as a virtual in base class, and then see when you call the delete on this developer tester manager, does the destructor of the respective types or of objects is called or not. So I leave it for you as an exercise. Do let me know how you like this video. If you like, please give a like and subscribe for such kind of new and informational videos on C++ design pattern, data structures and algorithms. I'll see you again in the next video. Do like and subscribe. Bye bye, and have a good time ahead. Thank you so much.